In this part of the training video, I'm going to use a real address project to demonstrate how users gather project-related information and enter into the TRT BOM generation tool. The site we're going to use is located in Illinois. This is the picture getting from either a site survey or it's readily available from like Google Map and other third-party mapping applications. You can basically get an idea of the dimension of the roof and the shape of the roof. And you copy the TRT BOM2 templates into a project working file and using relevant information in the file name. And you can start using the tool. To generate adequate TRT product BOM for a specific PV project, users need to provide adequate information about the site, the building, PV module used, and TRT product of your choice. The BOM tool uses Input Sheet tab to collect user input and provide mounting span check to make sure ASC mechanical requirements are met for the project site. The input sheet has several building blocks for the projects. Take customer input for the project-related information, the load specifications, the PV module specifications, and the general building information, plus the selection of TRT product lines. It also provides a dynamic span check for user input desired span to make sure it meets the mechanical requirement. Let's move into the details how to enter each building block. For product information, you can enter your product name. Basically, we're using Pinehurst as a product name, and this will be a first project 001, and the actual address is 4424 Pinehurst. It's at Lovers Park, Illinois. And some other information you can get from the ASC website. ASC website provide the key design parameters for the load specifications. Depending on the states that your project is at, check with your state which ASC code is current for your particular state. This tool currently supports ASC 7-10, 7-16, and 7-22. After you select the corresponding ASC code for your state, you can access the ASC header tool website one click to this link. Yeah, this is a free website that provides the key design parameters for ASC standards. So you basically just enter your address, 4424, Pinehurst, and you will automatically search the address. And you can select all the load type. And risk category for most residential, we select category 2. And site soil class, if you don't know, just leave the default. And this will be the standard you select in our BOM tool. So those two has to match. and you can view result. So this gives you the key design parameters. And you can look at summary report, and you can also download the full report. It'll take 30 seconds or so to generate report and download to your download folder. Yeah, it's in your download folder. From this report, you can get all the related design parameters the Excel tool needed. It's always a good idea to save you hazard report in the same project folder you are working on. So you move the report from your download folder into your project working folder, and you have it there. From the ASCE hazard report, you can fill in the site-specific information such as latitude, longitude, elevation, and all the load specification parameters. If you are familiar with the parameters, you can enter the data directly from the website or extract it from the hazard report generated and saved. And if you're not familiar with those parameters, all the cells with the red triangle at the upper right corner give you help. Basically explain what the parameter is and what it's used for, and all those parameters can be derived from the hazard tool generated the full report. The next building block we're going to cover is the solar panel for your project. You may notice the data fields are color-coded. The dark orange means required field. The light orange means optional. For solar modules, there are two ways you can enter the solar module data. One is select from the embedded built-in database. We have few already embedded into the tool, like QCell. We can select manufacturer QCell. Then you can select the model of your choice. Then the corresponding data will be populated from the database. Or you can enter the module information on the fly by selecting custom, customer manufacturer, and the custom module. Then you use the bottom table to enter the module information on the fly. It will automatically sync to the upper table, so it make the engineering calculation correct. Like we can change the weight of the module to like 30 pounds. And you can see it automatically filled in the module specification field. So it will make the calculation correct. To add your preferred manufacturer and solar panel model into the database, you can contact TRT support. We can help you build up the database so you don't have to enter every time. Yeah. After selecting the PV modules, we're moving to the racking selection, which is the sole purpose of this tool. As important as this, it's actually a not complicated process. In the upper right corner, the racking information selection, you actually just need to select the desired TRT product lines. From the pull-down menu, you can select our rail-based system, rail-less system, and if you are working for a tile project, you can select the tile hook product line. After each selection, it will automatically give the name of the product line you are selected. For this project, we're going to select the rail-based system, which is the TRT02 product line. And the orientation and for the rack layout will be selected and in the layout tab, so it will automatically populate this field for you, reading from the layout. And all you need to do is to make a few choices, like the length of the rail. Currently we have 7.5 feet and 14 feet selection. And also you can select the color of the rail. Currently we have mill finish and black anodizing finish. The last two fields you can enter if you use the microinverters, and you can count the number of microinverters per panel or per 2 panel or 4 panel. So you can give a number of microinverters you're going to use, and also the grounding lugs you plan to use based on your layout and the grounding points on your roof. The beauty of this tool is with very few product information input, it will automatically generate the complete BOM with all the accessory count for your project. The last building block of the input sheet is the building information. Here, you enter the general building dimensions, your roof type, shape, and roof type covering material, and the roof pitch. Roof pitch only takes degree as input. To help you convert the roof pitch into degree, you can reference this table here. Currently, the roof covering material, we support shingles, tile, metal, and standing seam metal. Roof shape type cover hip, gable, and monoslope roof. The roof member give you a selection where you want to put your mounting bases. It could land on rafter or OSB board or plywood board. One of the key features of the input sheet is the desired span check. After entering all the project-related information correctly, you can test out the mounting base span using the desired span length field, which is highlighted in yellow. You can start with a wider span, like 72 inches on the rafter, and the tool will calculate based on the engineering requirement and immediately tells you if this span you selected meets the code requirement. If it's not meeting the requirement, you can reduce the desired span. Let's put the 24. So with the narrower span, you can see all the zones on the roof is safe to put the panel with this racking base span. And we can play the middle number 48. This basis tells you with the 48 span on a rafter, you can safely place solar panels on zone 2, zone 1 of the roof, which is typically the majority area of the roof. This gives you optimized BOM. Then you can move to the detailed layout of each solar panel areas for your projects.